My name's Ed Burns, and I'm very happy to, as Yara said, and the many lovely introductions. Thank you for my friends that I've known for so many years, um, and having the chance to be in the TDC 2007 and here 13 years later, and many, many miles and transformations later for all of us. And that's really the topic of the talk, transformations and adaptations. So I'm very happy to be kicking off the Future of Development track today on Thursday. And this topic is wars I've seen from Java EE to Spring and more. Azure has you covered. If you're curious, I've uploaded the slides to SlideShare, and that's what this AKA link is up here. So I'll get right into it. I'm very glad that you've chosen to spend a little time with me today, and this is how I plan to spend our time together. I'd like to give a brief overview of my personal journey and how I came into the cloud, and then ways in which the cloud disrupted all of us, enterprise software, and then using this metaphor of wars, which I will put in quotes, and I'm going to then spend more of a drill down and summary on some of the specific aspects of the cloud and Java that we offer on Azure. And then finally have some Q&A afterwards. So I'm very excited with the opportunities of the online TDC hop-in platform where the Q&A can be more interactive than it would be in person. Okay, so this is my brief professional biography here. I've had the pleasure of being in this industry for a long time, and I've got to see a lot of transformation over that time. And my journey personally started out on the client side. I was very fortunate to be an undergraduate student at University of Illinois in Urbana-Champaign when the first web browser was happening, and CSA Mosaic, and worked on the X Windows system version of that piece of software after all of the Mark Andreessen and Eric Bina and all those guys had left, but I did know some of them in person. Then graduated and went out to Silicon Graphics and worked on a web authoring tool, and eventually moved into Sun in 1997 and started working on their Sun AOL Netscape partnership, the first version of the Java plugin, which was for running applets, which were big back then. And then had a chance to move into the server side, and that's where I've been ever since. So the client to the server and now into the cloud. And I think that's one of the mottos that our Microsoft CEO Satya Nadella has: intelligent cloud, intelligent edge. And it's just very nice to have had a little bit of time in all of those worlds as we've grown as an industry. So the moral of the story here is you must constantly adapt. You don't necessarily have to frequently change jobs, but companies need to adapt too. The pace of change is ever accelerating. With the pandemic, many of the businesses that are out there that are still trying to survive and adapt have done a decade worth of digital transformation in the scope of a year. The pandemic has accelerated all of this kind of transformation to the cloud. And so being inside Microsoft during that time, it's been like a tsunami wave coming up, and any cloud provider probably can say the same thing. The demand has increased, and we've had to work very hard to meet that demand. But Microsoft has done a great job. We haven't had any huge outages, but yet things have scaled up dramatically. So let's go into some detail here. The first perspective I wanted to give, which is the birth of a big thing. This was the Mosaic thing I talked about. This was the first graphical web browser. You could think of it as really the invention of the image tag, being the thing that took the web from text, which was like, Gopher or IRC or, Waze kind of text-based UI, and then finally added images. And once that started, everything kind of proceeded from there. Style sheets, applets, all of the interactive web stuff. But some of the reasons that it was successful was, this is the first key ingredient that I observed personally, was it was easy to author. If you wanted to create your own web page, you could simply copy and paste and view source, and then you were on your way. And so that factor of being easy to start and improve, rapid iteration was the key ingredient for the initial early web. Okay, there we go. So now moving on to the server side, this is a funny example of the very first e-commerce application that was deployed on the web as we know it now, in the sense of using HTTP to get all of the interchange going. So we had a email to fax gateway provided by the computer science department and CSO, and you could just basically send an email to this address and it would send convert it to a fax. You could specify the phone number in the subject, I believe. So with the introduction of CGI and the ability to write a Perl script that would send an email, we were able to stand up a very simple way to order a sub sandwich from Jimmy John's, which was a campus sub shop. So this was where we took the web and made it into a very basic way to do commerce. Now, there was no payment involved in this. You had to go there and pay the person when you arrived, but the idea was the core, and it was there. Then eventually moving into the birth of the monolith. So in early 1998, I think it was, and into 1999, IBM, who has a venerable history of building enterprise platforms, of course, going back to the 1960s, they had a technology platform they called Project San Francisco. And Project San Francisco was a way to do enterprise applications in Java. And eventually this became J2EE. It became this multi-vendor concept, which from the beginning had a strong notion of community governance. And that was the capital C community is one of the things that we're celebrating here in TDC. And that's also been one of the key ingredients of success in the Java platform, is that it's not just one vendor. It's not just one supplier. It's a whole raft of contributions from all different kinds of perspectives and stakeholders. And that multi-vendor community governance, community process has been something that has been a part of it from the beginning and still continues to be. Now, Spring came along at the same time. Rod Johnson had written this book, J2EE Design and Development, and he had a sample application, running application in the book to do it with EJB. And while doing that, he recognized, well, okay, there's a lot of ways this could be better. A lot of duplicate XML, a lot of keeping things together, keeping names in sync in several different places. And if you're getting a bit of a flashback, it kind of sounds like the way Kubernetes is now. It was a complex platform, and it could benefit by being given a single vendor look in terms of consolidating things. So that was the insight the Spring team had, was we could take this multi-vendor thing that is Java EE, ride the crest of those marketing efforts, and differentiate with operational excellence. And that was the first war that we all are still talking about, the Spring and Java EE competition aspect. And I'll have some more details on that later in the talk, of course. But I want to get into the war that I was most familiar with, and that is the so-called Web Framework War. I've not been involved in this space in a while, but I remember it very vividly. And in the early 2000s, there were a lot of different Java web frameworks out there. Tapestry, Wicket, JSF, Struts, WebWork. There's probably even some more. And we also had a few different ways to do rich client. We had AWT, we had we had Eclipse RCP, then we had Swing. And so all of these different frameworks created a component ecosystem, and people could choose which one they wanted to do. So it was a way to allow the public to see the vitality of things. And the first point I want to bring here is having a framework war is actually a good thing in hindsight, because if you have enough people that are caring about something to fight about it, then it's probably worth learning about the space in general, right? So if there's a framework war about what's the best way to do a web UI when your business logic is written in Java, then it's probably a good idea to have the concept of a web UI with your framework written in Java. Whether or not you choose a specific one, that's another matter. But it gives the reader a cue that it's worth researching it. So if something has enough passion about it, then it's worth learning about it. So I mentioned things that I've been lucky to see the birth of, and another big thing was really the birth of the cloud. Now you could argue that the cloud was invented in the 60s when IBM did its first System 360 virtual machine architecture. And that's certainly a valid argument. You can say that, but there's more rigor to the definition that I will get into. But this here is what I call the first containerized architecture. This was the Sun Utility Computing. It actually is a data center in a shipping container. So a lot of times people use Docker and they show images of container ships and such. But in this case, this actually was a physical container that you could put on a truck or a helicopter and hook up power and cooling and network, and then you would have a powerful data center on demand. And so this idea was in 2004, but it was before its time and also at the wrong home. Sun was a hardware provider through and through and never got away from that. Even though they had lots of excellent technology that was on the software side, their business model was very heavily involved in moving hardware boxes. So good idea, wrong time, wrong place. Now, fast forward to 2019, I have been working on Java EE for a long time and wanted to get outside of the monolith. So now I'm working at Microsoft, have been since June of 2019, and I'm very excited to be helping make Azure a great place for Java, which will be the last third of this talk. All right, now I'm going to take a quick pause, and normally if I was in person, I'd ask if anyone had questions now, but I'm not sure how to do that with this platform. So maybe grab some questions and put them in your text buffer for when we get to the Q&A. This is what I talked about with the rigorous definition of what a cloud is. I think it's worth repeating, even though we're many years into the cloud revolution now. It's just worth taking a look at what this National Institutes of Standards and Technology definition is. And this is why that container thing and earlier iterations of what we called cloud back then did not really meet the definition. So something that's on demand, meaning you don't need to hire a salesperson to get access to it. Something that you can just spin up when you need it. Something that's broad network access. It's a precondition. There's no notion of really disconnected operation in classic cloud in this definition. It's something that's you have broad network access as a precondition. Something that offers resource pooling, whether it's network, disk, CPU, any kind of resource that you would need is coming from a pool, and you're either sharing a part of it or you're getting all of it, depending on how your contract is negotiated. Rapid elasticity and totally auditable. And that last piece is really the thing that has transformed development the most. Because if you are even older than I know Bruno had mentioned Uncle Bob during the introduction. Uncle Bob probably remembers the days when you had to write I/O routines in assembly, and your performance mattered because every cycle was completely precious because of the user experience degradation if you didn't write it well. Well, we went through a phase in software development where you could just kind of be lazy and not have to worry about that. But now we're back to that. The cloud has brought us back to the notion of every instruction is important. But it's not so much because of user experience. Rather, it's because of the economy. So now it is actually more expensive to write fat and lazy code than it would be before. So that's, given developers an opportunity to lose some fat and get some lean and agile code back into their portfolios. And that's this billing aspect sort of ties into the commoditization of all aspects of IT infrastructure. So now any kind of part of what you would need to do enterprise IT is commoditized and auditable. And this is one of the reasons why I believe Kubernetes has become so popular rather, because it really is a system for doing all of these things, keeping with the cloud definition, but also doing it in a cross-cloud way. And that's something that Brendan Burns and the community of people that have been developing Kubernetes for a long time have really done a good job of. It is the base level cross multi-cloud platform that allows all of these kind of things to be audited and spun up and spun down while keeping the cloud definition. So let's take a few slides worth of content on before and after cloud and look at a few different questions. So how and who you pay for the software. Before the cloud came along, you would buy a single license and have people on your IT staff locally to maintain it. With the cloud, it's basically you're renting the software instead by subscription. And this aspect of the cloud transformation would not have been possible without all of the effort that was put into HTML5. You probably remember a few years ago when Web 2.0 was a hot term, and these technologies such as HTML5 and then later, more currently, Electron have enabled near desktop parity for software distribution. Now, for me personally, as someone who's worked in Java for a very long time and seen the power of things like JavaFX and the programming model that it offers, I look at Electron and I'm like, yeah, it just shows me what Java could have been if we had somehow done things a few differently in terms of the cards we played, that is Sun, to get things more widespread. But in any case, Electron does offer the cross-platform UI experience, and you can build very advanced apps in it. There's no question. There's plenty of apps that are built using that. And that's what this how and who you pay for software was enabled by one of those, HTML5 and Electron. Now, how you obtain the software once you've paid for it. Before the cloud, you would have to just install and maintain the packages on site. And after the cloud comes along, it's the containerized software. So you're outsourcing the environment that the software runs in terms of what it is in the Docker containers that comprise the software. How you get access to it. Prior to the cloud, you had to have your own data center and your own staff to maintain that, cooling and network and all of those kinds of on-site things. And I mentioned the acceleration of digital transformation due to the pandemic. We have a lot of customers that were already signed up with data center exit plans, and they've had to sort of reprioritize how they want to do those. If they want to accelerate it to get out of the data center because it's more expensive to maintain staff because there's all those additional safety protocols to keep them going in, or another strategy they've adopted is like, yes, we're just going to pause this and reevaluate data center exit once we get other things figured out in terms of how to operate during the pandemic. But if you take the pandemic aside, the idea is to virtualize the data center and move it to infrastructure as a service. So there is a well understood path that I'll talk about later in this presentation about lift and shift to infrastructure as a service, and then lift and modernize or lift and improve when you're going from on-premise to a more advanced architecture. So trying to do more than one thing at once. And it depends on your maturity level if you can handle that or not. All right, the Battle of the Titans. This is the war section here. So these are the belligerents, the battlers. So on the Java side, we're talking about Spring and Java EE. And on the non-Java side, we have all these different programming environments: Ruby, Net, PHP, Python. All right. And so the battlefield, this is the heart of the talk here. I wanted to talk about this. What is the battlefield for these wars? It's your very heart and soul. That's a very broad statement to say, but yes, we as developers are passionate about software. In fact, you have to be, because if you're spending this much of your time on it, you better enjoy it and better be passionate about it. And so the belligerents are, that is the people that it was in the previous slide, they're fighting over access to that part of you. Some would call this mind share, but because it consumes so much of our lives and time, and as we all see with the pandemic, that's very finite. And we know a lot of choices with, how we spend our time are even more difficult to make now in the world where we find ourselves. So that's why the wars that the different software developers or software vendors are fighting in to get access to your mind share or heart and soul are so important. So the analogy I'm going to use here is the military-industrial complex. And I would like to say in this analogy that the software makers and platform providers are really the weapons makers. They are really building the tools that you are using to solve problems and go out there and fight your IT battles. So there's a very interesting article or a speech by former US President Eisenhower about the military-industrial complex and the risks of that. So if you want, take a look at this bit.ly link. We'll take you to that speech, and it cautions about monetizing the weapons makers. And so in this case, the weapons makers are monetized as well, but not for the purpose of harming anyone, but rather for the purpose of creating value, and that's real exciting. So before the cloud, we had all these different Java app server vendors: Spring, Tomcat, Red Hat, IBM, BEA, Oracle, Sun. And then we had these non-Java runtimes. They were all battling for the same piece of your interest. Then we had hardware providers and network providers. And now in the cloud, we basically have consolidated all of those things and stacks into what I'm calling the major cloud vendors: Microsoft, Amazon, Google, and secondary or specialty cloud vendors. And this includes the hybrid cloud case as well. All right, so this is the wars that we all know about. WAR files that contain jar files, and ears that contain wars, and then the big famous make jar not war of Spring Boot. Well, I'm really not talking about that. I'm actually talking about this kind of war here, the battling, the fighting. So we've seen these kinds of articles, various smackdowns. In fact, I'm very honored that as far as I can tell, I coined the term Web Framework Smackdown in 2008 or something, and that has been a meme that's continued. And so the one that I'm going to talk about next is the Java EE, Jakarta EE, and Spring Framework War. But I've also had a, let me see, just want to make sure I get the points on this. Right, so even in the cloud era, these kinds of wars are still being fought, right? So you have Jakarta EE that's getting off the ground now, and you have all the different belligerents that are hedging their bets with various microservices frameworks. So you have Helidon and Quarkus and a few of those other kinds of things, Micronaut, for example. And then you have Spring Boot, Spring Cloud. They're all in the same kind of space trying to go after Java-based microservices that run in containers. But interestingly, even in the Spring framework, you have some key dependencies on Jakarta EE APIs in terms of servlet and JSP. And so the point I want to make here is that the difference between a development process with a real, not just pretend, community accountable development process, like the specifications and the expert groups, Java EE had that with JCP, and Jakarta EE has that with the Eclipse specification process. But Spring has always been a little bit closer to Python in its development process, with having a more single vendor, benevolent dictator for life kind of approach, like it was Guido in Python for a long time. Now, another way to approach this was with JBoss. They have embraced the community aspect a little more, where they had Hibernate, which was their thing, and then they really put the whole spirit of that into JPA, Java Persistence Architecture. So even though there's still quite a few people that are running plain old Hibernate out there, it's pretty much the same feature comparison with JPA. So if you have any Java EE app server, it's going to have the JPA architecture, which will give you everything that Hibernate has, but the vendor neutrality as well. Another war I've seen is dependency injection. So JSF 1.0, way back in 2004, had this concept of managed beans, which was a fully fledged, although feature sort of poor, implementation of dependency injection. You could inject properties with getters and setters, and you could specify the beans, and they'd be wired up when you hit the page. And Spring 1.0 was the same idea with terms of XML-based injection of dependencies, because annotations hadn't been invented yet, right? Now, that was fine, but then we realized we could do a little better, and with many different vendors doing the same thing, the idea with the JCP was, let's standardize on an API and that everyone can use, and developers can learn once and then take their skills across lots of different platforms. So in spring of 2005, Bill Shannon, rest in peace, and Roberto Chinichi, also rest in peace, and I went over to Google, where Bob Lee was there, and we had Ron Johnson there as well, and I think Gavin King may have been there as well. And we were trying to get this meeting, try to get Spring and JCP on board with doing a standard dependency injection spec. But what we ended up with was JSR 299, CDI, and JSR 330 JavaX inject. So, it would have been better if we got everyone together and didn't have that difference. But I can state from firsthand experience working with the Spring guys over the years that they never fully embraced the JCP lifestyle, even though Spring depends on quite a few Java EE APIs. They contributed. We had a lot of contributions for JSF from Keith Donald and Spring Web Flow, and but it was always kind of cautious, like not fully embracing it like JBoss did. So that is just something I'm sharing from personal experience. That is an aspect of the war fighting. All right, I talked about the web framework wars, both on the Java side and then the non-Java side, and I kind of feel like these have really fizzled out at this point, with Angular being, I'm sorry, not Angular, Electron or React being the two winners on this. And as much as I love all of these Java ones, I'd say in terms of number of deployments, gross number of deployments, the non-Java ones have more of them, although there's still perfectly useful cases where the Java-based ones make sense depending on your developer skill set and tools, and I have a whole nother talk about that. It's about finding the right fit between the developers you have, what they know, and the problems you have to solve. And that really counts for more than anything when it comes to tool selection. So another war was the how to do REST in Java. So we had REST Easy, we had JAX-RS, and then we had Spring MVC REST, 3 different ways kind of doing the same thing. And that's just the way it turned out. We have all of them still existing. We have, there hasn't been one clear winner there. And finally, another war is microservices versus monoliths, right? And this is interesting because the belligerents sort of span across time, from pre-cloud to post-cloud. So we had microservices before, it was called SOA. and now we've got monoliths, and there was an initial huge amount of hype about microservices, and some people were early adopters and got in and recognized the complexity. Others stood on the sidelines and said, I'm just going to see how I can go with my monolith. And now they're all existing, and I think the industry has a better understanding of what is appropriate for each case. So there is something to be said for waiting and seeing which approach fits your style. So after the cloud comes in, really it's all of the above. The old belligerents are still there. They just have been absorbed into other entities. But the cloud providers have now inserted themselves into the fray. So you could ask, isn't this just another war? Now it's a war between cloud providers? Well, somewhat, but you have to look at what you're comparing. We have made progress as an industry. So instead of debating about what goes into the boxes on the architecture diagram, we're debating about the arrangement of the boxes themselves. It's kind of immaterial what you're putting inside the boxes thanks to containerization. And a lot of times if you make a technology choice, you can keep going with that while you adapt it and put it into a larger perspective with an orchestration platform like Kubernetes, for example. But when you compare cloud providers, you want to compare price, and you want to have a cloud provider that meets you where you are. This is another way of talking about the importance of tool selection, right? If the cloud provider is really an all of the above cloud provider, we want to meet you where you are. So if you're using Java, we want to make sure we have a good, broad, and deep set of offerings for Java developers. If you are using .NET, of course, you're using Microsoft anyway. But if any of the other platforms, any cloud provider, whether it's Amazon, Google, or Microsoft, or any of the other tier providers, they need to meet the developers where they are. So from my particular cloud provider's perspective, we want to be the best place for all of your Java workloads. So infrastructure as a service to the cloud, containers, and also platform as a service to the cloud. So let's drill down to what Microsoft has to offer in this regard. We'd like to say that we have Java on Azure for wherever you are in your cloud journey. We have a lot of different things, and there's Java in all of these, of course. I'm only going to cover a few of them. So we'll be covering Java EE on Azure Infrastructure as a Service. We'll be covering Azure Kubernetes Service with Java, Azure Red Hat OpenShift, and the Azure Spring Cloud Service. The other aspects all can run Java just fine, and there is also App Service that has a huge amount of Java support, but I'm only going to be focusing on these four right now. So here's the first one that I'm working on most closely, and this is Java EE on Azure with Oracle WebLogic. So we have a number of Azure Marketplace solutions that Oracle has developed with Microsoft, and it's been a very exciting partnership, and I'm very happy to be working on it. These are published and maintained and supported by Oracle, and you can choose your WebLogic version, Oracle Linux version, Java version. When you're deploying the thing, it's bring your own license, so it's very appealing for any existing customers that want to migrate into Azure. And if you're curious about it and want to learn more, you can check out that Azure WLS link there, and that's a contact me page, and fill that out, and we'll get back to you and help you learn more. And there's also, of course, plenty you can read that is linked from that page as well. So the idea is it's simple to start, right? You can choose from a simple, fully functional instance of WebLogic. It's got the admin server built in and ready to go, and systemd is configured for automatic restart. So it provisions the VM, and you're ready to go, just like you would be on site. No containers, no Docker files or anything, container registries or anything like that. It's just a plain old thing you're already used to. We also have an offer that supports clustering. It comes up with a fully functioning clustered multi-domain thing. You can choose to have Azure Application Gateway standing in front of it as a load balancer. It automatically provisions the app gateway, sets up the backend pool to be the worker nodes in the cluster, and sets up the health check and everything that works there out of the box. You can add and remove nodes later. You can do this with an ARM template. It's not a matter of automatically scaling up and down, although it could be automated that way if you wanted to invoke the ARM templates, because it is all procedural if you want, but it's not something that's like a key, easy part of the platform where you can turn a dial and say scale up and scale down, because it is VM based, so you want to have a little more control for that. This is kind of what the UI looks like in the portal. It's a very simple deployment UI. And this is what the architecture is. So you have an ARM template, which includes a number of VM extensions, which is basically a script file that can do things in the cloud, such as create resources, wire them together, deploy things, and wire things around. So it sets up the admin server, the managed servers, NICs, spins up the VMs, and sets up the storage as well. And then, of course, this is your basic WebLogic architecture, where you have the node manager with an admin server, and it can refer to any number of other constituent servers in the dynamic cluster. So we have a dynamic cluster offer, which uses the WebLogic dynamic clustering feature to use the scaling within the predefined VM set that you already have. So to summarize this offer, we have 4 different offers in the marketplace. We also have a collection of base VM images that these offers use. And so you can get more details on that with this aka.ms link here, aka.ms/AzureWLS. The next thing I want to talk about is Kubernetes, the industry-leading orchestrator. And it's, as I mentioned, some of these things before: portable, extensible, and self-healing. The self-healing is really simply a way for you as a software provider to say, okay, you can ask me if I'm well or not by responding to this health check. So it lets you parameterize the question of, is the system healthy or not? That doesn't mean it will automatically do it for you, but there's a space for you to fill in that logic. That's what it means. So we have the Azure Kubernetes service, and the way it works is you have the standard Kubernetes API endpoint, and it provides automated upgrades and patches. So there's always a new version of Kubernetes being rolled out, and you can control how you want that. And the control plane that you get is just sort of the no additional charge for getting into the Azure Kubernetes service. Now, let's take a look at how WebLogic and Coherence would work on the Azure Kubernetes service. I mentioned we have marketplace offers for WebLogic on Azure VMs. We also are working on doing a similar offer using the WebLogic and Coherence Kubernetes operators, so you can do the same thing but with a containerized runtime. So with this, you have kubectl, and you have the Oracle WebLogic Kubernetes operator, which will automatically stand up all of this, and so creates the domain for you and makes it so you can have either persistent volumes for your domain configuration or have everything containerized, depending on how you would like to configure it yourself. So our roadmap is to, we already have database connection, we have Active Directory integration, we have App Gateway integration. We are also working on having ELK for logging and caching with Oracle Coherence. So those 2 features are in the process now. The next thing I want to talk about is OpenShift. Now, OpenShift is a layer on top of Kubernetes. It's really kind of an ease of use layer that turns Kubernetes into something that looks more like an app server. It gives you a nice console, and it has a very nice experience for deploying and managing operators and applications. So it's a cool concept, and we have Azure Red Hat OpenShift, which is a way to run OpenShift on Azure. So with this offer, we're basically, Microsoft and Red Hat have partnered to do most of the work of running an OpenShift deployment for you. So it's kind of like OpenShift as a service, basically. We give you Azure Active Directory, Key Vault integration. You just have to define your app and how you want to do user management and quota management and your application lifecycle. But all of the other aspects are handled for you. So what are those other aspects, right? So this lets you focus on the applications yourself. You get premium support from Red Hat. You can rapidly deploy and scale containerized apps and services. And you have this whole substrate of goodies that you can access from your containers. Whereas Microsoft and Red Hat focus on all the infrastructure here, the orchestration, all of these foundational cloud concepts, and down to the physical infrastructure. The next aspect I'd like to talk about is Spring-based microservices development. So Microsoft Azure has really great support for Spring Boot and for Spring Cloud. Boot is designed to get you up and running as quickly as possible with minimal upfront configuration of Spring. And it really came about as an evolution of how can the process of Spring itself be made easier. So Spring Boot predates the concept of microservices. So in some sense, if you look at Spring Boot as a microservices platform, it's really kind of the oldest one. But also in that sense, it does have some wrinkles in it that are not present in those so-called cloud-native microservices platforms like Helidon and Quarkus, for example. But, you know, evolution versus revolution. It's something that's always been and always will be present in software. Now, Spring Cloud is a service that lets you do really the Spring Boot microservices approach in a cloud environment. And we have Azure Spring Cloud Service for that purpose. Now, similar to what I mentioned with Red Hat OpenShift, there's a high amount of effort. If you wanted to run a Spring Boot in a Spring Cloud environment, there is a lot of application infrastructure that you have to manage. You know, all of these different dashboards and service registries and brokers and API gateways. There's a lot of trouble there, and it's also difficult, even if you maintain it yourself. If you have a problem with your app, it's difficult to troubleshoot that kind of thing. So with Azure Spring Cloud Service, it's really a fully managed service for Spring Boot-based microservices. The idea is it's a fully managed infrastructure. It gives you lots of integration choices and gives you lots of ease for application development and monitoring, most importantly. This is what the architecture looks like. Similar to what I showed with the Red Hat, we have a partnership between Microsoft and VMware. And with Spring Cloud Service, we're doing most of the work, and you just have to focus on application iteration and debugging. So you have built-in service bindings for all of the different Azure services you'd like to have. You can do source to deployment by going straight from Git, and it will automatically build and create your jar and deploy it using the VMware Tanzu build service. Underneath, this is running on Azure Kubernetes service, and we provide all of this kind of integration for you, and you just have to focus on application iteration. Okay. So this is what the lifecycle management looks like. Source code, I missed that one, that's Tanzu build service. The CI/CD pipeline creates the jar artifacts, which goes straight into the AKS user cluster, which stands up the Eureka for service discovery. Also has a config server using the Spring Boot config pattern. And the CI/CD is, of course, intimately wired in with how you're doing your application development. Monitoring. I mentioned the importance of monitoring. You can use Azure Monitor to get your application insights, and you can aggregate your metrics, and you can also see how calls are flowing through your microservices. These will show different colors when you have problems with your throughput, and you can figure out where they are. And you can, of course, set up circuit breakers and other kinds of microservice patterns to mitigate these effects. And here's what the roadmap is for Spring Cloud. So we are really close to general availability, coming up to Q4 2020. I really do ask you to please take a look at this survey if you're interested in doing Spring Cloud, Azure Spring Cloud service, or you can scan this QR code. One of the big features that we have completed now is private network. So without this, you really can't claim to be your enterprise ready. So with private network, you set up a bridge between your private data center on premise, where you might have your database or persistence or identity management could be running on site, and then you have a way to have a secure connection to the Spring service in the cloud that's running there. Okay, so here's our summary. The thing I want you to take away is be willing to adapt and change your focus. It's not so, it's really not possible anymore to just focus on one thing. Things have progressed to the point where being an inch wide and a mile deep is not a tenable career strategy. So it's better to focus a little more on breadth instead. The cloud has disrupted everything, you know, I've seen this firsthand, being on the inside of the monolith and recognizing I need to get out and have a broader focus. So be ready for making changes there. Don't get distracted by wars. Find the real value and focus on that. So whenever you see the tech media talking about trade-offs between different technologies, try to take a step back and look at the space of all of the players, not just the individual participants that are in that particular article. And finally, I'd like to just leave you with Azure as a great cloud for Java workloads. So that is my talk.